அருள்மிகு பழனியாண்டவர் ஆர்ட்ஸ் காலேஜ் ஃபார் உமன், Palani, PG Department of Chemistry. I am Mrs. T. Anandi, Assistant Professor, PG Department of Chemistry. Today's topic is High Performance Liquid Chromatography. The technique of HPLC was developed by Shaba Haworth, Grigland and Huber in 1969. The first mixture to be separated by Haworth group were nucleic acid associated with thyroid functions. Characteristics feature of HPLC: high resolving power, speed of separation, accurate quantitative measurement, repetitive and reproducible analysis using same column, applied to the separation analysis of very complex mixture. Determination of multiple components analysis are completed in few seconds with excellent precision and accuracy. Introduction. In this technique, pressure is applied to the column, forcing the mobile phase at much higher rate. The pressure is applied using pumping system and usually from 300 to 400 atmosphere. The pressure is varied to provide the linear flow rate of the mobile phase. This is the diagram of HPLC. Principles of HPLC. The pump delivers the solvent from reservoir at the constant flow rate, which is smoothed out by means of the damping device. At the place where the maximum pressure develops, a safety valve is incorporated. The inlet pressure of the column is monitored with manometer. After leaving the column, the sample components are monitored by detector and their tracings are drawn by recorder. Solvent reservoir. Solvents containing substantial amount of dissolved air. These air bubbles affect the column efficiency, also the solute direction. So some of the convenient solvent reservoirs are equipped with degasifiers. Solvent can be degassed by heating, stirring, subjecting into vacuum, ultrasonic vibration or bubbling helium gas before pouring into the reservoir. Solvents used in HPLC must be of high purity. High pressure pumps. The pump is one of the most important components of HPLC. It should be chemically inert. High pressures are required. Its performance directly affects retention time, reproducibility and detector sensitivity. Various pumping systems operate on the principle of either constant pressure or constant displacement. Constant pressure pump. These pumps facilitate delivery of the solvent at the constant pressure. A gas at high pressure is introduced into the pump which forces in turn the solvent from pump to column. Constant pressure is maintained throughout, which causes a decrease in the permeability of the column with time. These pumps provide a uniform and pulse-less solvent flow. Constant displacement pump. This pump displaces the constant amount of solvent from the pump into the column. They maintain the constant flow rate. Commonly used constant displacement pumps are motor-driven syringe pump and reciprocating pump. This is the syringe pump. They usually consist of a large syringe-like chambers equipped with a plugger that is activated by the screw-driven mechanism powered by the stepping motor. The disadvantage is limiting solvent capacity. This is the reciprocating pump. Most widely used consists of small chamber which the solvent is pumped by the back and forth motion of the motor driven. The solvent is direct contact with the piston. Advantage: small internal volume, constant flow rate. Disadvantage: produce a pulse flow. Sampling device. The sample is introduced in the flowing stream of solvent with the injector by the following injection method. Syringe injection, micro volume sampling valves. Syringe injection. The sample is injected with the help of micro syringe. After the sample is injected, the pump is switched on. The procedure known as the stop flow injection. Micro volume sampling device. These valves enable samples to be introduced reproducibly into the pressurized column without interruption of mobile phase flow. The sample is soldered at the atmospheric pressure into the external loop in the valve and introduced into the mobile phase by an appropriate rotation of the valve. The volume of the sample introduced may be varied by changing the volume of the sample loop or by using the variable volume sample valves. Valve injection is preferred for the work because of its higher precision compared to the syringe injection. Columns. The stainless steel precision board columns with an internal mirror fissure for the efficient packing are normally used. The column lengths are 15 to 50 centimeters. If urine, blood or crude cell extracts are used as the samples, which result the clogging and the loss of the resolving power of the column. To prevent, a short column length of 1 to 2 cm and internal diameter equal to that analyzer column is generally introduced between the injector and the analytical column. The short column is called ground column and is packed with the material with which analytical column is packed. Column packing material. The column packing material serves as a stationary phase or support the stationary phase should be pressure suitable. The packing used in the modern HPL consists of small rigid particles have a narrow particle size distribution. Three forms of packing materials: porous polymeric beads, porous layer beads, total porous particles. Gradient isostatic elution. The gradient isostatic elution is one in which the composition of the solvent is changed continuously or in the series of steps. Reduction in HPLC. The signals from the detectors are detected as the deviation from the baseline.